I'll do, let me see if Tim Test has. Yeah, this will be a good one.
Why is it called T1 versus T2?
I don't remember what they stand for. I think it's like test 1 or test 2 mode. But like I was telling Travis, you can think of it as like T1 mode is I'm like right up next to the robot trying to like debug something. That's why it has the reduced point-to-point motions, because the point-to-point motions are super fast. T2 mode is like, okay, I'm stepping back from the robot. I don't want to verify everything at full velocity. My program works at full velocity before going to auto mode. So essentially one is a reduced velocity mode. The other one is like, with an enabling switch, run what will be run in auto mode. Yeah. I don't remember if they just stand for test 1 and test 2 mode, or if there's something else, a German word or what. Okay, so I will run. Let's see. We have air on. The spindle is correctly clamped. So let's run just this real test program in T1 mode. So it does a BCO run. And that's, when you enable RSI, we'll go over this more when you guys get to executing, but when you enable RSI in T1 mode, you have to confirm the enabling. So anyway, spindle is on, turning, I'm running through a part program, and I drop the pendant. It decells the spindle, it stops the robot on path, so you shouldn't have any problem. If you want to come back up, you have to press the enabling switch, acknowledge that you're getting ready to start the program again. Now when you press this button, that's when the spindle will turn back on. So the spindle will turn back on, but what you'll notice is that we are halting the robot until the spindle gets back up to speed before we continue motion. So theoretically, if you stopped halfway through a cut for some reason, and you're coming back out, press the button, it gets up to speed, and then it continues the motion, even though I'm holding the button down. So we do that, you'll see the program override flickering whenever if you let go of the button in T1 mode, it stops motion. But you'll notice, that's the way we built the function. If you hit E-stop, you should actually still be on path, even though it was an E-stop stop. Same thing, undo the E-stop. You have to confirm that the E-stop has been pressed. When you prep, you have to undo and redo the enable.
Does that use the braking resistor when you stop it?
Sorry, what?
Does it use the braking resistor when you stop it like that, the E-stop?
It may be using it, but I doubt it.
Okay. It's like determined by the driver.
Yeah. Yeah, from that speed, I doubt it. So anyway, we E-stopped mid-motion during a cutting motion. We undid the E-stop, we confirmed that we undid the E-stop, and then we'll press the green play button again, and it'll do the same thing. It'll turn the spindle on, but it won't continue the motion until you get back to the program speed that you were at. That's the end of the motion, so now it's turning the stuff off. But anyway, if you E-stop or if you drop the trigger, we stop the robot. Once the robot is detected that it's stopped, then we decel the spindle.